All right, lesson 5.3, solving systems of linear equations by elimination. So we'll get into this here. We'll treat it, it'll be very similar to 5.2 as far as kind of the process, I think. We'll do, there's a few steps involved. I'll try to color code them, make it easy, hopefully easy to follow. We'll do a part one where we kind of get exposed to it today. We'll try a few problems on the homework, and then have kind of a follow-up day where we maybe clarify some stuff, go over nothing necessarily new, but just kind of reiterate some of the big points as far as what I'm seeing on some of the homework that you guys submit. So let's get into it. Let's take a look here. We'll actually start by reviewing our substitution one because we're still working on that, and I know a lot of people are trying to get that one figured out still working, so we're going to keep working with it. There'll be one of the substitution questions on the homework, so we might as well, again, it doesn't hurt to review it here. So this warm-up, just getting warmed up, getting us using some of our skills, solve the system by substitution. So we really have to watch now here because it's going to, this will be our, after today we'll have 3 different ways to solve a linear system. One using elimination after today, but we should already be familiar with substitution and obviously graphing, which is very recognizable in the sense that you would have to have a graph to do that. The part that a lot of us are still got to keep working it with is checking the solution. That's always part of these problems. So let's take a look. Let's do this one. We don't need to spend forever here because we've done 2 different video lessons going over these. The reason that this one is a great candidate, and we'll see here today once we get into kind of the new stuff, where there's advantages and disadvantages to each type. This one's a great candidate for substitution because you already have a y by itself. So we see y equals negative 2x minus 9. I say, great, the y is by itself. I'm going to solve this by substituting this right in here for this y. Okay, so that's been our step. Now, 6x minus 5 times, not y anymore, but negative 2x minus 9 equals negative 19. Okay, so it was kind of set up really conveniently for us to use substitution. So how do we do this? This one's actually kind of tricky in the sense that I got to make sure I'm distributing this minus, it's a minus 5. So whether you switch it to plus minus or just know that that's a negative 5 getting distributed there. So I'm going to go 6x, now plus 10x, and then plus 45 equals negative 19. Combine our like terms here. 6x and 10x is 16x plus 45 equals negative 19. We'll subtract 45 from both sides of the equation to get 16x. Let's see, hit the old calculator here. Negative 19 minus 45, negative 64. And then we'll finish, at least this first part, we're not done, by dividing both sides by 16 to get x equals negative 4. Okay, that's the big portion. That's one of the that's just one of the steps that take probably the longest. After you substitute, combining like terms, it's a lot. If you've been doing them, you should hopefully be like, yeah, it's always kind of the same step. I distribute, combine like terms, move the constant, move the numbers together, and then divide. So that's kind of been the pattern, at least. Now, again, a few of us are stopping here and saying, oh, sweet, I'm done. There's a second substitution, so I'm coming back up here, and this step is actually part of today's as well, that we found out what x is. Each answer, though, has an x and a y component. Okay, so we found the x portion. Now I got to figure out what the y is. So I'm going back up here and substituting again. This step definitely is not as many steps. So negative 2 times, let's see, x, which is we're saying now is negative 4 minus 9. So negative 2 times negative 4 equals positive 8 minus 9. So we're saying y equals negative 1. Okay, so I like my answer. I mean, I don't think I made any mistakes of negative 4, negative 1. That's kind of the last part is, well, we're not, again, not done, but I can do that. I can write my answer here as far as I think that's the answer, negative 4 and negative 1. The last part is the check. And again, this is another step that's part of the homework as far as I want you to check. I'm not just doing it for fun here. It says it right here in the directions, check your solution. So going back to the original, the 1 is always going to be easier. Y, let's see, y is negative 1, and I'm just substituting again. Negative 2 times x. This is the one we use to find the negative 1. So we know this one's actually going to work out. So I'm okay even right here just saying, hey, what is negative 2 times negative 4 is 8. 8 minus 9 is negative 1. So that one does check out. We knew it was going to. It's this other one that we really haven't done a whole lot with in a while that we got to check. So 6 times x, let's see, is negative 4. And this, again, this will be part of what we do today. There's always going to be a check involved. Times 5. What did we say y was? Times y. So y is negative 1. And we're hoping that that all comes out to negative 19. So this is negative 24. If I evaluate each portion, negative 5 times negative 1 is positive 5 equals negative 19. And it checks out. That's a 24. I know my handwriting. You should see what I'm writing with you. It's kind of hard. But negative 24 plus 5, negative 19 equals negative 19, and I think we're okay. That's what we were hoping would happen. So that's, I know that's, you've seen a lot of those in the last couple previous notes and say, well, that's nothing new. Why spend 5 minutes on it? A, because we're struggling with it a little bit, but also I wanted us to see that that one was set up nicely to do substitution, right? We've seen ones where we've got to do some rearranging to get a variable by itself, and it's not always as nice of a start, okay? That's where this other method maybe will come into play. So let's do the notes portion of it. Okay, it's a couple steps, and I think we'll do it like we did the last section where I kind of maybe do a step. So this, write a step, do it, and then we'll jump to an example where you can kind of see it in action. Okay, so we are using, these are our notes, and it wouldn't be a bad idea for us to copy these down. We're solving systems now, not by substitution. That was this up here, by elimination. Elimination. Just as an overview, I think people like this one a little bit better. A lot of people say they think it's easier, which is fine. There's nothing wrong with that, having something a little easier. I hope you feel the same, and I guess I'll let you kind of make that call once we do it. So this first step is we kind of saw it in the last one. We'll do this one first step in green. Why not? This is kind of one of those if necessary steps. Necessary. And it's not like an optional, but it's like it kind of depends on what the problem is presenting you, okay? And there's kind of two things that are involved here. So it's like step one, part A and B. Line up, and I'll show you what this means, but line up X, Y equals and constant terms. Okay? So what that means is line them up. We want the x's above the x's. We want the y's above the y's. We want the equals above the equals. And then the constant, remember, is just a number. We want the numbers above the numbers. So I'll kind of show them head to head. The one we're going to look at, I think, already has this done, this first step, if necessary. So you can kind of see it. We've got x's above the x's. We've got y's above the y's. We've got equals above equals, and then constant above constant. So that's definitely not something that we're going to have to do. Here's this if necessary coming into play. It's not necessary. It's already lined up for us. Whereas the one that we did to start, you can kind of see the stuff's not lined up, right? You got y, x equals above the y, like stuff's not lined up here. So this one that we solved by substitution would require us doing this first step, lining up our x's, y's, and equals. So that would require us, you know, adding a 2x to both sides to bring this over to the other side, basically, to get started on this one. Add 2x, and then the x's would be above each other, the y's. So for the most part, we're going to see them, at least today, I think, where everything's kind of lined up, which is a good thing, right? It's one less thing to do as far as like a step. Along with this step one, and this one usually is, well, I guess it'll be 50-50-ish kind of on today's notes. So line everything up if necessary, but also kind of if necessary, in this one we will have to do today, not on this first example, but the next one. If necessary, multiply one or both equations by a number to get, so you can squeeze it in here, opposite coefficients on one of the variables. Okay. And again, I know it's a mouthful, but so I'll try to clarify and explain what that means. We want to get opposite coefficients. So opposite, remember, means different signs. So a positive and a negative number on one of the variables. So let's take a look at this first one. Again, I don't think it's going to be necessary. So if I look, I've got a positive 3 on the x's and a positive 3 on the x's. Those are not opposite coefficients. It's the same. We don't want the same. We want opposite. So if I look at the y's, though, I can see I've got a +2, a positive 2, and then I've got a -2 on the y's. Okay? So that's what we're hoping to have. You don't have to have it on both. We want it on just on one of the variables. So we have our step 1 done for us here. Okay? Step 2, this is where we kind of have to do some of the work here. And again, that could potentially be a longer first step. So and we'll do one where we have to do that. Just so don't worry about that. I'll make sure we see an example of us doing this. Step 2 then, okay? After you have everything lined up, if necessary, and you've multiplied, you've kind of gotten to this situation, we are going to, this is always part of the elimination portion, so you'll always do this. Add the 2 equations by basically add each column. Whoops. Add each column. So let's just do that before we add a little bit more here. So add the 2 equations by basically adding each column. So on our first example, we'll maybe do 2 of them just so you can kind of see how this works here. So we need to add, it's like old school, like top down, add the equations. What's 3x? And it may be helpful to put a plus here just so you remind yourself that I'm adding. What is 3x plus 3x? It's not 0, that's 6x. Okay, what is positive 2y plus negative 2y? It's 0y. So what we can do, here's why this is called elimination, because we're eliminating that variable. 2y plus negative 2y is 0y. It's gone. We can copy down the equals. And this one's kind of a unique one too. This doesn't always happen, but when I go 4 plus negative 4, I get 0. Now again, that doesn't always happen. That's kind of unique, and I'm glad we're seeing it actually, because sometimes we see it and say, oh, something's wrong, I made a mistake. Nope, we just add it. Whatever you get is what you get. So 4 plus negative 4 is 0. All right, so that's kind of that first of part 2 here. Add the 2 equations, add each column. So you add them up, and then let's say kind of as a follow-up to that step, solve for the remaining variable. Okay? And usually, actually not usually, always, it's going to be like a one-step solve, which is kind of nice. It's different than the substitution. You look at our work for substitution, holy cow, that first step was da-da-da-da-da-da-da-da. Really here, and this is exactly why people like this one a little bit nicer, or a little bit more, is because get this x all by itself. This is this 6x equals 0. So how do we get this x all by itself? I divide both sides by 6. The 6's cancel, and I'm left with x equals 0. Holy cow, that's nice. That's a really nice step because it was just a one-step solve. All right, so that takes us through our step 2. Add the two equations top down at each column and then solve for the remaining variable. Okay? Step 3. No matter whether you're using this method we used above, this step 3 is always the same. We're basically down to this spot where we have an x equal to something. How do I get the y here? I took it and I plugged it back in. I'm going to do that same thing here. I get to go back and pick one of the two equations and substitute this back in. So let's write it out. Step 3, substitute the solution. Whoops, I don't want to be doing that. Substitute the solution, from step 2 into either of the original equations. Okay, so let's do that. I mean, that's just a straight up substitution, so this should just take a second. So I already have half my answer. Now I'm coming up. This one, there's not really an easier or a harder one to do, but we're going to take this 0 now and plug it into one of the two original equations. So we're going to have 3, but instead of times x, we know what x is equal to. It's equal to 0. So 3 times 0, and making sure I can see what I wrote here, but it's plus 2y equals 4. Okay, so that's kind of takes us up to what we've written so far in the notes. Just substitute in. I could have gone here. It's not going to make much of a difference. Substitute the solution from step 2. Can you read all this? I'm trying to say it because my writing's not great. Substitute the solution from step 2 into either of the original equations. Solve for the remaining variable. Okay. So what that means is, to finish off that step, is we basically got rid of this x. We plugged it in. We substituted it with a 0. So now it's just kind of like we've seen in the previous substitution, third step. Get this solved for this y now, and that'll be our answer. So 3 times 0 is 0. So 0 plus 2y equals 4. I could probably just get by without even writing that, because 0 plus 2y is just 2y equals 4. And then divide both sides by 2 to get y equals 2. So kind of like before, I'm feeling pretty good about my answer of 0, 2. What are you going to guess is our last step? Right here where it says check your solution. Okay, so what's a good one to finish with here? Let's do blue. Check your solution by plugging x and y values into original equations. Okay, so that again, these last couple steps are really the same as substitution. So I like our 0, 2. Let's do our quick check. And it's kind of the same where one of the two is going to be a lot quicker than the other. Actually, with both of this one, it's not going to be bad because of that 0. So let's check. 3 times 0 plus 2 times 2, we should hopefully be getting 4. Sure, 3 times 0 is 0, 0 plus 4. I'm okay with us kind of jumping to right here because I understand that you can type this in on a calculator and get, even if you didn't see it right away, but 4 equals 4. Yep. This other one that we haven't really plugged stuff into, so let's just check and make sure that one works. 3 times x, so I'm going to replace that x with 0, minus 2 times, okay, 2 should be equal to negative 4. So 0, basically 0 minus 4, yeah, it's going to check out. Negative 4 equals negative 4, it checks. So overall work-wise, is it less? It depends. It kind of depends on this first step, just like with substitution. This one, you really shouldn't, with elimination, you shouldn't really have any distributive property, which I think is nice. People appreciate that. They don't, it's just one less kind of bigger step to do. So usually your first kind of portion of work is going to be less. This one might be a little bit more. Let's do one more, just so you can kind of see it with going through all the steps here, at least one of these kind of simpler types, and then we'll do one of the harder types. So step 1, line everything up. Let's check it out. I'm going to try to keep the same colors. We went green, purple, red, blue. We can do that. So green, any first steps, x's above x's, y's above y's, equals above equals, numbers above numbers. Yep, we're good there. And then here's where, again, these are going to be a little bit nicer and easier because we already have, there's a negative 2 here, there's a positive 2 there. That's what we're looking for. We want that to happen. It doesn't really matter what these other things are. So our step 1 is done. Step 2 says now, here was kind of the nice step of add them up. Okay, add your columns. So we're jumping, and again, it's kind of nice that we can go right to this. What's negative 2? Put the little plus here to remind yourself that that's what we're doing. Negative 2x plus 2x is 0. Gone. I'm not going to write it. I'm just going to say, like, hey, those eliminated. Be careful here in a situation like this. What is 3, positive 3, plus negative 1? There's a little negative 1 in front of that y there. So it's really 3 kind of minus 1. We're going to end up with 2y. And you could just do it as 3 plus negative 1. It's going to work out that way. And then same thing here. Just be careful. Don't mix it. When the minuses start to come in here like this, people get mixed up. What's 4 plus negative 8 is negative 4. And these ones are kind of a nice ones to start. I purposely made the numbers a little bit smaller so we could maybe see and do some of the operations without a calculator. But now the last step is, at least for part 2, is just to get the y, whatever variable is by itself. So divide by 2 to get y equals negative 2. It's a pretty nice step, right? There wasn't a whole lot of work involved there. Step 3 really is what we're up to. Go back now and substitute what we just figured out. In this case, it was y. So we saw one where we found the x first, we found the y first. It doesn't matter which one you find first. It kind of just depends on what the numbers, how they work out. But now take this and go to either one. It doesn't matter which one. I'm just going to go to the top one because it's easy for me to draw. And I'm going to plug this in for y. So work-wise, it looks like this. Negative 2x, I don't know what x is, plus 3 times, instead of y, we're going to say that y is negative 2 because that's what we think it is. And then we're going to say that hopefully, it should come out to 4. So evaluate this here, negative 2x, I can't do anything with that yet, plus 3 times negative 2, so that's really like negative 6. So here's what I'm saying, this third step is a little bit longer than maybe the substitution method. But either way, it's get the x by itself now. So plus 6, negative 2x equals 10, and then we'll divide both sides by negative 2 to get x equals negative 5. Okay, I'm feeling good. I think, I don't know. I mean, again, we could have made a mistake here, and this would work out to a nice whole number like that, even if potentially if one of my answers were wrong. So I feel good about it. I like it. I always kind of say the same thing. I think our answer is okay. I don't If I would have made a mistake, I would have fixed it. But here's where we'll know for sure. Okay, a check. Go to the, let's go right here, -2. -2 times -5 plus 3 times, what's y? We're saying is -2. And that should hopefully come out to 4. So a little bit more kind of going on here. What's -2 times -5? 10. What's 3 times -2? -6. Yeah, 10 minus 6 is 4. So 4 equals 4. That one, first equation checks out. Let's just do it on the bottom one. Be careful here on this one in particular, just because you end up, this first part's, okay, 2 times -5. So 2 times -5. But then remember, it's minus, I don't know why it's making those dots here, minus y, which we're saying is -2. So we got to just be careful there with that double minus going on, equal to -8. So evaluate each part individually. So 2 times -5 is -10. But then remember, we all know this, minus -2 is really like plus 2 equals -8, and then sure, -8 equals -8. Okay. One thing I should mention, and I know we're kind of far into substitution and elimination here. If you check something out and it doesn't work, right? Let's just say I screwed up. Maybe I think I maybe did one on the substitution, but let's pretend like my number was wrong. I misdivided, I misadded. If this does not happen, where you get the same number, that's basically telling us we got to go back and figure out what happened. Something happened. I made a mistake somewhere, and it's a lot of times really hard to tell, because obviously you wouldn't have done it if you thought it was a mistake. So a lot of times it's almost easier to not necessarily start over, but you really have to kind of go through your work and see, okay, did I add these here? Did I add correctly? Did I divide correctly? So the whole purpose of a check is that if this doesn't check out and I don't get the same numbers, I need to go back and fix something. Okay, let's do one more. Both of these have been kind of that quote-unquote easier type where I didn't have this first step, if necessary step. I am going to ask you on the homework to do one like this, so it's probably makes sense for us to try one like that. So I'll do what I've done in the past. Like, let's look at, here's the homework, your first two homework ones. You can kind of see are two that we just kind of like, that we were just working on, where I've got that initial first step done for me. So on the homework, you're looking at the 4 and the -4. They're opposites right off the bat. Everything's lined up. Not here, but then I've got my -5 and my +5. I think there's enough space to kind of do it all and check. But here, to kind of preview what we're about to do next, what happens when, all right, I've got a 1x over a 2x. I can't eliminate those. I've got a 1y over a 7y. I've got to do something here before I can eliminate anything. Same thing, I've got a -3 and a -9. Those are not opposites. 7 and 5, those are not opposites. So what do we do in that situation? So let's take a look here, where we kind of got to do this first step. Green, purple, red, blue, just so I can remember it. All right, let's jump ahead here a little bit. Here's the situation we were just talking about. So I'm going to need my green pen just because I can see what's going to happen. If I look at my coefficients, there's a -10 and a -5. Right now, if I were to add these, you're going to get -15x, you're going to get -3y equals 24. Well, that didn't eliminate anything. That doesn't help us. So here's where that first step is. Everything's lined up, but let's do this. Multiply one or both of the equations by any number. We can pick anything we want to get opposite coefficients on one of the variables. So again, that's a mouthful. Let's make sure we know what that means. So I'm looking here, whoops, not this one. And I'm looking for maybe a relationship that would be kind of nice. And the one that jumps out at me is this 3 and this -6. Okay, we said we want opposite signs. Well, this one's positive and this one's negative on the y's, right? There's a +3 and a -6. So I kind of already have that taken care of, the positive negative portion. I just need to make, this would be great if this was a 6, right? If it was +6 and -6, we'd be sitting pretty. So that's, I'm just kind of taking you through my mindset there is, let's do that. We can do that. Let's make this a 6. How do I turn this 3 into a 6? I need to, whoops, not do that, but multiply by 2. okay? And here's kind of the spot that, and I would be doing what I'm doing right here, is I need to make sure that all three pieces get multiplied by 2. So here's how that, and that's, you were just seeing this for the first time, so that's kind of the key to this first step here. So 2 times negative 10x, I'm kind of just following my arrows here. I'm going to rewrite this top equation as negative 20x. That didn't help me. We didn't even talk about that. It doesn't really matter what that is. Here's the one that's going to be helpful, though. Instead of plus 3y, we're going to go times 2 and go plus 6y. And then this is the one that everybody always forgets. Don't forget about right here. What is 2 times 1? 2, okay? So that's what I mean. We multiplied this top equation, and it's not always by 2. It could be by 3, by negative 3. It could be positive, you know, whatever. But basically it's saying we multiplied everything by some number to create this situation. Let's see what happens. I'm going to just take this one and line it up right underneath it. Negative 5x, because we didn't do anything to this one, minus 6y equals 23. But by doing that, does everyone see that? Was purple my second step? I think so. That when I go to now do what we were doing, when I go to add, I'm going to get these to disappear. So here's what I'm already up to step 2. Add your columns. Be careful. What's negative 20x plus negative 5x? Negative 25x. What is 6y plus negative 6y? 0. It eliminates. What is 2 plus 23? 25. Hey, look at that. We eliminated one of our variables. We could not have done that from the get-go. That wouldn't have happened if we just added right off the bat. Okay? From here, everything else is how we did it above. Okay? So I'm going to divide everything, just whatever it is to get the x by itself. So divide by negative, 25. This cancels, x equals negative 1. Okay, so everything now is consistent with what we've already done. From here, let's go to this one. I'm gonna take this x now. Here's my substitution. I'm gonna plug it into one of the two. Go back to the originals. Don't go back to these ones. Go back to the originals. So I'm gonna go here and say, all right, negative 5 times x, which we're hoping is negative 1, and then when I go minus 6y equals 23. We're left with just one variable to solve for. So let's do it. Negative 5 times negative 1 is positive 5. Don't shortcut these steps here. Equals 23 minus 5 minus 5. Let's draw a big equal. So just watch. Be careful. Negative 6y, that negative's got to trickle down with it, equals 18. Divide by negative 6. Divide by negative 6. To get y equals negative 3. All right. What are we up to? Blue for our last step here. Here's a check. Oh, let's write our answer, what we think it is, negative 1. And I'm okay. I mean, write your answer because we're feeling good about it. That's a lot of work we've done, and we've gotten to what we think is the answer. Let's just kind of confirm it one way or another. I should maybe set one up for next time where I purposely get it wrong and see what happens on the check. We'll see if I remember that. Check. Go back to the original. Negative 10 times, let's see, x we're saying is negative 1 plus 3y. Whoops, with 3y, we know we're thinking y is negative 3 equal to 1. So we ended up with negative times negative is positive 10. 3 times negative 3 is negative 9. Yep, 10 minus 9 is 1. 1 equals 1. Good to go. This bottom one, I think we're going to be in good shape because we kind of used this one to help us get here. So I think we're going to be in pretty good shape. Negative 5 times x, which is negative 1, minus 6 times negative 3 equal to 23. So let's see, negative times a negative is positive. Negative times a negative is positive. And then if you need to, grab your calculator. 5 plus 18 is 23. It checks out. I'm going to do, so you obviously at this point, we're kind of, that'll take us through those first 4 problems. So you obviously can go back and watch, you can kind of see. I'm going to do just the first step on one more note here example, just so you can kind of see it. How do we get these to eliminate? Because you have choice, really. You know, I kind of just picked that y and saw, hey, you know what, if I double this, I'm going to get 6 and -6. But you really have 4 choices. You could multiply. I could have multiplied this bottom one. Was anybody thinking this? What if I multiplied this bottom equation originally by -2, which would have created a +10 right here? So there's different things you can do to kind of start. So I want us to at least just see that first step. I won't do a full problem, but just so you can at least see that first step once. But that'll take you through the first 4 problems. There is a back. Look at that. I didn't remind, in case you were just looking, you didn't see that or whatever. There is a second part. You know, the back side is just review, one of each. We got to keep working. We don't want to just kick this aside. A substitution. Okay, so a substitution. I got all the space here. Use it. I'm not just doing that for fun. That's there because it's going to take. You're going to have to rewrite one of these equations. Hint: I would probably look at this one right there and getting that by itself. Substitute it. Watch our notes from the beginning of today. And then I got a graphing one. So again, go back through. There's a lot of space here because there's some rewriting components and check components. 6 problem assignment. You got several days to do it. Let's just do one last one here of just that first step so you can see it because we hadn't really seen it other than just that one time. So last thing here, I'm trying to finish up, keep it relatively doable as far as time video wise here. I'm looking at my variables. They're lined up? Yep, y's over y's, everything's lined up. But the problem is we can't add them right now. There's a 1 plus 4 is 5. That's not going to eliminate, and then 4 plus 1 is 5. So this one's actually a good illustration of we got all sorts of choices. So I'm going to say, you know what? Why don't we take, let's just change it up a little bit and multiply this second equation. What if can I make this a -4 right here? Yeah, I think so, because then 4 plus -4 would eliminate. So that's kind of my thought process. I think a lot of people may be looking at the top one and saying, hey, why don't we multiply the top one by -4? Because that would create a -4 right here and a +4 right there. So again, there's choice in how you do this. So I'm going to say, hey, you know what? Let's take this bottom equation and multiply it by -4. And then I would do what I'm doing right here is where you kind of draw the lines to remind yourself that I got to do this to every single one. So just kind of rewriting this, -4 times 4 is -16x. And then here's the one that's going to help us. -4 times y is just -4y. And then the last one, -4 times 13 is -52. So this bottom equation, you're like, well, what the heck? Why did you multiply everything by 4? This times 4, this time, well, times -4, this times -4, this times -4, this times -4. What the heck? Well, if I just take this top one now and just reline everything up, x plus 4y equals 22, you can hopefully see that, oh, now when we go to add these, what's 1 plus -16? All right, whatever, that's -15x. It's this one, though, now. This is going to eliminate. What's 4 plus -4? 0 goes away. And then here we've got -30. So I'm not going to finish from there. You've seen me do that now 3 different times. I just wanted us to see at least one last example of us kind of doing that first step. Okay, pick one of your variables. There could be a case, and I hate to go like just totally off the cuff here, but what if it was 2x and 5x, and you wanted to get and you know there's a plus y equals whatever. You could multiply both equations by something. I could multiply this top equation times -5. I can multiply the bottom equation times -2 and get -10s on both of these. You could do that too. So there's options as far as what you multiply. As long as you multiply everything by the same number, you're not going to make a mistake. Okay. So there you go. You have your assignment. It's posted there. It's 6 total problems. If you're watching the video, though, you should have an idea of the amount of work that you should be showing. That's why I'm giving you 5 days to do it, because I want you to have some time to do it right, do the checks. Yeah, do it the right way. So That's what I have for you. So we'll come back next week and just do a recap of 5.3 and see where we're at. All right. Have a great weekend.